All right, so let's dive into something that's totally changed the world, coding. I mean, you're interacting with it right now just by listening to this. But here's the thing. Most people have no idea about the wild ride coding has taken to get here.
Yeah. It's really remarkable how much we just take it for granted.
It really is.
Yeah.
Like, we're talking time travel levels of change.
Right.
From, like, literally punching instructions into paper.
Right.
To the AI that seems to write itself these days.
Yeah. Like a hidden language that's kind of underpinning everything.
That's exactly what it is. And this deep dive is your crash course in that language, the history of coding. We're going to be using this text to trace how it all began, the big breakthroughs, and how those moments led to the tech we have today. Now, you could be a coding pro already. You could be totally new to this. Either way, this is about understanding those key moments that changed everything.
Yeah, and I think a lot of people think of coding as a very modern thing, but the roots go way back.
Yeah.
Even before computers as we know them.
Which brings us to like the OG programmer, right? Ada Lovelace. I mean, talk about ahead of her time. She was working on a machine in the 1800s that never even existed.
Yeah, that's right. Ada Lovelace, she worked with Charles Babbage, who designed something called the Analytical engine. It was a mechanical computer.
Wow.
Far cry from the electronics we use today.
Yeah.
But even though the engine was never actually built, Lovelace, she saw its potential. And she created algorithms for it, essentially instructions.
Hold on. So she was writing code for a computer that didn't exist. That's next level.
Visionary.
Visionary. But if there weren't any computers, like how did people actually program back then?
Right.
I mean, were they using those punch cards?
Ah, yes, the punch cards. It sounds so archaic now.
Yeah.
But it was groundbreaking at the time. You know, imagine translating complex mathematical calculations into patterns of holes punched into paper.
Oh my goodness.
And each card represented a single instruction for the machine.
I can't even imagine the patience
Right.
I'd have for that. And like one wrong hole and it's game over.
Pretty much, yeah. A single misplaced punch could throw off an entire calculation. But this is also where we see early forms of debugging.
Interesting.
You know, they developed systems to detect and correct those errors, which, you know, laid the groundwork for the debugging tools we rely on today.
Right.
It's a testament to how, even in those early days, humans were obsessed with, like, controlling and automating these processes.
It's funny to think about it. And now we're still doing the same thing, just on a much larger scale. But, okay, let's move on from punch cards. We eventually get assembly language. What made that so different?
So assembly language was a major step forward because it replaced those raw binary codes with something a little more human readable.
Okay.
So instead of strings of ones and zeros, you had these things called mnemonics, which were short codes that represented machine instructions. It's like writing ADD instead of 011010001 every time you wanted the computer to add something.
Okay. I can see how that would make things a bit easier, but it still seems pretty intense compared to, you know, what we use today.
Absolutely. And this is where we get to the concept of abstraction. So each new generation of programming languages essentially creates another layer of abstraction, moving further away from the actual hardware of the machine.
Okay.
And this makes it easier for us humans to code because we're not bogged down in the nitty-gritty details of how the computer works at the lowest level.
So am I hearing this right? Like, learning to code back then with assembly language was actually harder than learning today?
In many ways, yes.
Wow.
You know, today we have sophisticated tools and languages that are more expressive and easier to learn. But the fundamental skills, right, the logic, the problem solving, that ability to think like a programmer,
Right.
those have always been essential.
It's like learning to drive a car. Like, modern cars have all these fancy features, but you still need to know the basics of steering, braking, understanding the rules of the road. Okay, so we've moved beyond punch cards. Assembly language made things slightly easier to understand. What happens next in this evolution?
Well, the 1950s and 60s saw an explosion of new languages. And here's where it gets interesting. Each of these languages was created with a very specific purpose in mind.
Wait, hold on. So coding starts to specialize. Like, we had one giant coding language, and then it branched out into all these different dialects.
That's a great way to put it.
Okay.
So you have Fortran, designed specifically for scientific computing, which was booming at the time.
Right.
Then there's COBOL, aimed at tackling the complexities of business applications. And for those early AI researchers, there was LISP, a language built for symbolic reasoning.
This is where things start to get really interesting, right? If you think about it, it makes perfect sense.
Yeah.
Scientific research was pushing the boundaries of what computers could calculate. Businesses were drowning in data that needed to be processed. And those AI pioneers, they were trying to teach machines to think.
Right.
Of course, they needed different tools for those jobs.
Exactly. This specialization was a direct reflection of how computers were being used. And for you listening, it's a great point to reflect on your own interests, right? Are you drawn to the data-crunching world of science? Or maybe you're fascinated by the logic puzzles that those AI researchers were tackling.
I love that.
You know, this history helps us understand the landscape of coding today.
Okay, so we've got purpose-built languages, coding's branching out. What's the next big leap? So last time, we traced coding's journey from those punch cards and the visionary Ada Lovelace to the emergence of specialized languages like Fortran and COBOL. But now be ready because we're about to hit the PC revolution and the era where things really take off.
Like, this is where we see coding becoming more accessible, more widespread, and more influential on our daily lives.
Yeah, and I remember this era well. BASIC.
Yes.
You know, my first taste of coding, trying to make simple games on our families like clunky computer,
Right.
It felt magical.
BASIC, which stands for Beginner's All-Purpose Symbolic Instruction Code, was designed to be just that, basic. You know, the goal was to make programming accessible to anyone, regardless of their background. And with the rise of personal computers, it meant that suddenly, anyone with a PC could give coding a try.
But BASIC wasn't the only language making waves at the time, right? Like, I remember hearing about C and how it was this powerhouse behind the scenes.
That's right. So while BASIC was opening doors for hobbyists and beginners, C was emerging as the language of choice for professional software development. It gave programmers more direct control over hardware and memory management, making it ideal for building complex systems.
And here's what blows my mind.
Yeah.
C is still relevant today.
Right.
Why is that? What made it so impactful that it's still used after all these years?
Well, C's influence is massive. Think of it as the foundation upon which so much other software was built.
Wow.
So operating systems like Unix and later Linux were written in C, and it paved the way for other languages like C++, Java, and many others. Its efficiency and flexibility made it incredibly powerful.
Okay, so we've got BASIC getting people excited about coding, and C quietly powering the tech world behind the scenes.
Yeah.
And then boom, the internet explodes onto the scene.
Yeah.
This must have been a game changer for coding.
Oh, the internet completely transformed the coding landscape. Suddenly, we needed new languages to build websites, create interactive elements, and manage data online. That's where HTML, JavaScript, and PHP came in.
Right.
You know, they became the essential building blocks of the web as we know it.
And this is where coding really went mainstream, right? I mean, anyone building a website, even a simple one, was interacting with code, whether they realized it or not.
Exactly. The internet brought coding to the masses in a way that no one could have predicted. And it wasn't just about consuming information anymore.
Right.
People were creating, sharing, and contributing to this vast online world.
Which brings us to another huge development, the open source movement. Right, this idea of sharing code freely,
Right.
allowing anyone to contribute to projects.
Yeah.
Linux is a great example of this, right?
Absolutely. The internet facilitated a level of collaboration and knowledge sharing in coding that had never been seen before. Linux, this powerful operating system, was built by a global community of developers working together, not by a single company. This open source approach really democratized software development.
It's amazing to think about how much the internet changed. Not just what we could do with code, but also who could participate in its development.
Right.
Okay, so we've zipped through a lot of history here, but we're not stopping there.
Right.
Now we enter the modern era, the time of like dizzying innovation and a whole lot of new stuff to wrap our heads around.
Hold on tight, because the pace of change really picks up from here. This era is marked by an abundance, some might even say an overwhelming amount, of new languages, frameworks, and platforms.
Which is exactly what makes this deep dive so valuable. Right? So let's break it down. Remember how we talked about specialization earlier?
Yes.
Well, that trend explodes in the modern era.
It's like the coding world went through a Cambrian explosion.
Oh, wow.
With languages evolving to meet these increasingly specific needs.
So give us a rundown, like what are some of the key players in this modern coding ecosystem?
Okay, we have Python,
Yeah.
known for its readability and versatility. It's become a favorite in data science and machine learning. Then there's R, a language built with statistics in mind, making it perfect for analyzing large data sets.
And let's not forget about the mobile revolution. Suddenly, like everyone's carrying a smartphone, which meant we needed new languages to build apps for these mini computers in our pockets.
Exactly. That's where languages like Swift and Kotlin came in. Swift became the go-to for developing apps for Apple's iOS, while Kotlin rose in popularity for building Android apps. Both languages prioritize speed and efficiency, which are crucial for creating smooth and responsive mobile experiences.
Okay, so we have this huge increase in specialized languages, but that sounds a bit overwhelming, for someone just starting out in coding. How do you even know where to begin?
It can feel daunting, that's for sure.
Yeah.
But the good news is you don't need to learn every language under the sun.
Right.
The key is to understand the underlying principles, the broader trends shaping the coding landscape.
So give us an example. What's one of those trends that stands out to you?
Well, one major trend that has made life a lot easier for developers is the rise of frameworks. Think of frameworks as pre-built components or libraries of code that simplify common tasks. It's like having a set of building blocks for software development.
Okay.
Instead of writing every line of code from scratch, you can leverage these frameworks to speed up the process.
So it's kind of like those meal kit services where you get all the ingredients pre-portioned and ready to go.
That's a great analogy.
Less time chopping veggies, more time enjoying the final dish.
Exactly. Frameworks like React, Django, and TensorFlow allow developers to build complex applications, websites, and even machine learning models without having to reinvent the wheel every time.
Okay, so things are getting more complex in some ways, but also more user-friendly thanks to these frameworks. But let's talk about the elephant in the room, AI.
Yeah.
Everyone's talking about AI these days, especially with tools like ChatGPT that can write code.
Right.
Does this mean human coders are becoming obsolete?
It's a question a lot of people are asking, and it's understandable given the rapid advancements in AI.
Yeah.
But the short answer is no. AI tools like ChatGPT are incredibly powerful, and they can certainly assist with certain coding tasks. They can generate code snippets, suggest solutions, and even help with debugging.
But they're not taking over completely?
Not at all. Human programmers are still the ones defining the problems, setting the goals, and making sure the code aligns with the overall vision of the project. AI can help us code faster and more efficiently, but it can't replace the creativity, critical thinking, and problem-solving skills that human developers bring to the table.
So it's more like a partnership than a replacement.
Exactly. AI can augment our abilities as programmers, freeing us up to focus on higher-level tasks like design, strategy, and innovation. And speaking of innovation, there's another trend in the AI space that's worth paying attention to.
Oh.
Tell us more. Well, it's the rise of low-code and no-code platforms. These tools are designed to empower people with little to no coding experience to build applications using visual interfaces and drag-and-drop components.
So kind of like those website builders where you can just drag and drop elements to create a web page without having to write any HTML or CSS.
Exactly. It's about democratizing technology creation.
Right.
Making it possible for anyone with an idea to bring it to life, even without years of coding experience.
That's incredible, but it also raises some interesting questions.
Yeah.
Like, does this mean everyone will need to learn to code in the future? Or will these low-code and no-code platforms make traditional coding skills obsolete?
Those are questions we'll explore further in the final part of our deep dive. But first, let's take a moment to recap what we've learned so far.
Great idea. I mean, we've covered a lot of ground today. From the early days of punch cards to mind-boggling potential of AI.
Right.
It's amazing to see how far coding has come in such a relatively short amount of time.
And it's only going to get more interesting from here. But before we get ahead of ourselves, let's take a step back and connect the dots. What are the key takeaways from this whirlwind tour of coding history? What does it all mean for you, the listener? We'll unpack that and more in our final part.
Welcome back to the deep dive. We've journeyed from the birth of coding with Ada Lovelace all the way to the modern age of AI and the rise of these low-code platforms.
Right.
It's been a whirlwind tour
It has.
through a world most people never even think about,
Right.
but one that shapes almost everything we do.
Yeah. It's fascinating how coding has evolved from something incredibly specialized to a field that's increasingly accessible to, everyone. And yet at the same time, it's also become more complex and specialized as technology has advanced.
Yeah. It's like this constant push and pull between simplicity and complexity. So for you listening out there, what are the big so what moments from all this?
Right.
What does it mean for us in the grand scheme of things?
Well, I think the core takeaway here is that coding at its heart is a tool.
Okay.
And like any tool, it evolves to meet the needs of its users. Whether it's scientists crunching numbers to unlock the mysteries of the universe, businesses streamlining their operations, or artists creating immersive digital experiences, coding gives us the power to shape the world around us.
But it's not just about what we can create with code, right?
Yep.
It's also about who gets to create.
Mm-hmm.
We talked about how basic opened doors for everyday people to start coding,
Right.
and how the open source movement fostered this incredible spirit of collaboration and knowledge sharing.
Yeah, that's a crucial point. The history of coding is intertwined with this ongoing struggle for access and democratization. As tools become more user-friendly and communities grow around different languages and platforms, the potential for innovation expands exponentially.
Which leads us to a question we've been circling around.
Yeah.
With AI becoming more powerful
Mm-hmm.
and low-code platforms making it easier for anyone to build things, what skills will be most valuable in the future of coding? Should we all be racing to learn Python, or will those skills be outdated in a few years?
You know, if we look at the big picture, I think it's less about mastering a specific language and more about cultivating a certain mindset.
Okay.
Adaptability is key. The ability to learn new languages, grasp new concepts, and be willing to pivot when the landscape shifts.
So don't get too attached to one particular way of doing things.
Exactly. The field is constantly evolving. What's hot today might be obsolete tomorrow. What matters is having that solid foundation
Right.
in problem solving, logic, and the willingness to embrace change.
Those are the skills that will always be in demand.
Exactly.
That's great advice for someone already working in tech. But what about, those who are just starting out? Is it even worth learning to code now with AI doing more and more of the heavy lifting?
That raises a really interesting question about the future of work in a world increasingly shaped by AI. While it's true that AI will automate certain tasks, it will also create new opportunities. Understanding how to leverage AI, how to collaborate with these tools, will be a valuable skill set moving forward.
So instead of being replaced by AI,
Right.
it's more about learning to work alongside it, finding ways to combine human ingenuity with the power of these new tools.
Precisely. It's about recognizing the possibilities and the limitations of AI and finding that sweet spot where human creativity and artificial intelligence can work together to achieve, amazing things.
As we wrap up this deep dive, I can't help but think back to Ada Lovelace. She imagined a machine that could think, a machine that could do more than just crunch numbers.
Right.
And in a way, we've kind of achieved that with AI.
It's incredible, isn't it? From punch cards to AI-powered tools, the journey of coding has been nothing short of remarkable. And the best part is, we're still just scratching the surface. Who knows what incredible innovations await us in the years to come?
Yeah, it's pretty mind-blowing.
Yeah.
So for you listening, as we close out this exploration of coding's history, what's the one thing you'll take away from this deep dive? What sparked your curiosity? What new insights did you gain?
For me, it's the constant tension between complexity and accessibility. Coding is becoming more powerful and sophisticated, but it's also becoming more user-friendly, opening doors for people who wouldn't have considered themselves coders in the past. It's an exciting time to be part of this world.
That's a great point. It's like coding is becoming both more specialized and more democratized at the same time. And who knows what will emerge from that dynamic interplay. So to leave you with a final thought, I think it's important to remember that coding, at its heart, is about human ingenuity. It's about our desire to solve problems, to create, to connect, and to leave our mark on the world.
Beautifully said. Whether you're a seasoned developer or just starting to explore this world, don't be intimidated by the complexities of coding. Embrace the challenge, nurture your curiosity, and remember that the power to shape the future is quite literally in your hands.
And on that note, we'll wrap up our deep dive into the history of coding. Thanks for joining us on this incredible journey through time. Until next time, keep exploring, keep learning, and keep coding.